Hello friends, this is Chandrapal Chauhan and today's topic is NFA to DFA conversion. Right. If in your exam, if the problem is like this, construct a DFA for the following NFA where M is equal to, here the set of tuples are given Q0, Q1, Q2, Q3. 0, 1, del, Q0 and Q3, and where the del is given in the form of this transition table. So first of all, we must understand what exactly the problem is, whether it is NFA or whether it is a finite automata or not. How we are going to come to know what exactly it is. First of all, we'll just find it out what is given here. Here it is given M is equal to this 5 tuples are there. In our NFA, we have seen that NFA is a type of finite automata which consists of 5 tuples. The first tuple is it is the Q, then sigma, del, Q0, and this is set of F. What does it mean? It means that Q is what? Q was the finite set of states. Here you will come to know that there are 4 states are there, Q0, Q1, Q2 and Q3. And sigma is what? Sigma was our this finite set of input symbol. That means what? Here we are having a string which will be generated in terms of zeros and ones. Del was your transition function. Transition function is given in terms of transition table. And the fourth tuple is Q0. What is Q0? Q0 is my initial state. So here I am going to denote my Q0 as initial state with the help of this arrow here. This is a standard symbol we are going to follow. If the machine is not given in terms of these tuples, if only the table is given, then we must know that which is my initial state. In your table, the arrow will be given to the arrow heading towards the state which will be treated as your initial state. Right. And this is the final tuple. The final tuple says that it is a set of final states. Here you are having only one final state. In some other problem, it is not fixed. Only one final state is there. In your NFA, you can have a multiple final state as well. But in this particular problem, you are having only one final state, and that final state is what? That final state is your Q3. So we'll mark here this Q3 is my final state, and star mark means that this is my final state and this Q0 is my initial state. So this problem is given, but we must know that whether it is NFA or not. So how we are going to come to know the given problem is NFA or not? So what is the basic definition of NFA? How the NFA is differentiated from your DFA? The NFA and DFA get differentiated with the help of this function only. This function is called as what? It's a transition function, right? And the transition function of your NFA works in this fashion. Del is what? Del Q into sigma. It gives you 2 raised to Q. What does it mean? That problem we have seen last time, right? What exactly it is? It says that from any state, Q is what? Q is a set of states. Q can be any state, and sigma is what? Set of input symbol. This sigma can be any input symbol. It may be either 0 or 1. After reading one input symbol, if the machine takes more than one transition means what? 2 raised to Q. 2 raised to Q is what? 2 raised to Q is a power set of states. Power set of states means what? If you are having a 4 states, 2 raised to Q, that means what? 2 raised to 4. It means it will generate 16 different states, right? So from one input symbol, from one state on one input symbol, your machine may take multiple transition, right? It may start from 0 to 15, right? So this here, from this definition of NFA, we'll come to know that once we see the table, we'll come to know from this Q0 on 0 transition, it is taking multiple transition. That means one transition is going to Q0 and other transition is going to Q1. If you are having multiple transition, or if you are finding out the multiple entries in the given transition table, that means what? This particular transition table belongs to NFA. Right. So what to do in this case? First, we'll just check it out. We'll just draw the graphical representation of this table. So we'll draw the transition diagram. We'll start from the Q0. On 0, there is a cell transition. It goes over here. On 1, it goes to the new state called as Q1. And on 1 also, it goes to the same state, that is Q0. From Q1, on 0, it goes to the next state called as a Q2. And on 1, there is a cell transition on Q1 itself. From Q2, on 0 it goes to the new state called as a Q3, and Q3 is my final state, and Q3 is denoted in terms of transition diagram by having a concentric circles. So Q2 on 0 it goes to the Q3, and Q2 on 1 it goes to the Q3 as well. So there are multiple, from 0 and 1, from Q2 it is going to the same state, that is Q3, and from Q3 on 0 there is no transition, but on 1 it goes to Q2. That means what? From Q3 it goes to Q2 here on 1. So this is the graphical representation of this table. So from this diagram only we can find it out. From this Q0 we'll find it out. On 0 it is going over here, but on 1 it goes to the Q0 itself. There is a cell transition, and on the same input symbol, that is 1, it is going from Q0 to Q1. That indicates that this diagram belongs to NFA, right? So what to do? How to convert the given NFA to its equivalent DFA? For every NFA, what the literature says that for every NFA there exists its equivalent DFA. But there is a standard procedure or standard algorithm we need to follow to convert the given NFA to its equivalent DFA. So what to do? So we start converting the given NFA to its equivalent DFA. For that, what we need to follow, we need to create a transition for the DFA, right? So we start from the initial state here. From this NFA transition table, what we do, we try to find it out, the transition on all the states which are generated from the given state. This is what sigma, this is Q on 0 and on 1. It is like this. What I am going to do here, I am going to copy the simply initial state, because initial states of NFA and DFA will remain same, right? So this is my Q0. I am going to copy here from Q0 on 0. It is going, there are two transition, but it is the DFA transition NFA transition table. What we are going to do right now, we are converting the NFA to its equivalent DFA. So whatever the transition table we are drawing right now, it is of DFA, right? So what to do here? I am not going to consider this now. Q0 and Q1 are the two separate states. Here they will be clubbed together and form a single state only. So this Q0 and Q1, here I am not putting a comma here. Here it was a comma, it indicates that these are the two distinct states. But here both this Q0 and Q1 is a single state, and it's a new state, right? So on 1 where it goes, it is going to Q0. Then, so here I am finding out this, whatever the new states I am going to get over here, I need to find out the transition for all the new states which are going to generate in my DFA table, right? So here I will find it out, this Q0 and Q1, this is a new state. So for this new state, what we do, we just find out the transition on this new state on 0 and 1 on all the inputs. So Q0 and Q1, this is a new state. So what I am gonna do, I need to find it out, what will be the transition on 0 from this newly generated state. So what we do, we'll just go to my the transition table of my NFA. What it says that on Q0, right? On Q0, on 0 where it goes? On Q0, on 0 it goes to this new state, this state called as what? Q0, Q1. That means what? Here I need to apply a del function. What del function says? Del function is Q0, Q1, comma, 0. I need to find out this transition, right? So this transition, how I'm going to find it out? I'll just find out this Q0, comma, 0 union del Q1, comma, 0. So I need to perform the union operation of these two. So what it says that Q0, comma, 0, here the Q0, comma, 0, where it goes, I am going to get the new state called as Q0, Q1. This is the next state that I am going to get with this del function, right? I am performing the union operation with del Q1, comma, 0. Del Q1, comma, 0, what it says that it is going to where? It is going to Q2. So this is Q2. So I am going to perform the union operation of these two. What I am going to get? Q0, Q1 and Q2. So this is a new state that I am going to get on this Q0, Q1 on 0. So I am going to write down this newly generated state here. Q0, Q1 and Q2. So in the same fashion, what we are going to do, we are going to find out the transition from this state on 1. So Q0, Q1 on 1. So we'll perform the same step, but I'll show you how to perform it directly by seeing the given transition table, right? So where I am now, I'm dealing with these two states, right? Q0 and Q1, and I want to find out the transition on one input symbol, right? So I'll take this Q0 on 1, where it goes? It is going to Q0 itself. And what is my next state? Next state is Q1. So I am finding out Q1 on 1, where it goes? Q1, right? So I am going to get two states, that is Q0, Q1. So I am going to perform the union operation of these two, Q0 union Q1. So I am going to get the new state called as Q0, Q1. So here I am going to write it down directly here, Q0, Q1 on 1. Right. So here, for this newly generated state, I find out the transition on both the input symbol, right? When this state is over, then the next next state is Q0, which is already been considered, right? So here, for the next step, what we do, we find it out, this Q0, Q1 and Q2, this is the newly generated state. So we have not yet find the transition for this state. So we'll try to find out the transition for this newly generated state, that is called as a Q0, Q1 and Q2, right? So here it is a combination of three states, but this is a DFA table. So what we do, we consider this is as a single state, right? And for this single state, again we are following the same thing. We'll refer the NFA transition table and we'll find out the transition on this state on 0. So here I am going to treat all three states, Q0, Q1 and Q2. Here the Q0, Q1 and Q2, I am having these three states on 0. Where I am going from Q0, Q1. From Q1 on 0, it is going to Q2. Q2 on 0, where it is going? It is going to Q3. So the union operation of these three, one is Q0, Q1, union Q2, union Q3. That means what? Q0, Q1, Q2 and Q3, that will be clubbed together, and I am getting a new state and called as what? Q0, Q1, Q2 and Q3. Right? So here, and the same time, what I need to do, I need to find out the transition on 1 in the same fashion, right? On 1, where it is going? It is going Q0, Q1 and Q2. It is Q0, Q1 and Q2. Here, on 1, it is going to Q0. Q1 on 1, it is going to Q1. Q2 on 1, it is going to Q3. So Q0, Q1, Q3, that is a new state. Q0, Q1 and Q3. This is the new state that I have got, right? So here, I have finished this. This is already been considered. Q0, Q1, Q2, that I have find it out. Q0, Q1, it is already there, right? So here, Q0, Q1, Q2, Q3. So for this transition, I need to find out for this particular state, I am going to find out the transition on zeros and 1. So this is what? This is Q0, Q1, Q2 and Q3. So for the same thing, again, I need to refer this table, Q0, Q1, Q2 and Q3. So on 0, I need to perform the union operation of all those states, right? So what it says that Q0 on 0, it is going where? Q0, Q1, Q1 on 0, it goes to Q3, Q2 on 0, it goes to Q3, right? So here, and Q3 on 0, there is no transition, there is null transition. So what I am going to do, I need to perform what? Q0, Q1, union Q2, union Q3. That means what? Q0, Q1, Q2 and Q3. All four states will club together, and that is the transition on 0. That means what? On 0, it goes to Q0, Q1, Q2 and Q3. Right. On 1, where it goes? I am going to consider all four states because this is my new state. Right. So I need to find out the transition on 1 from Q0, Q1, Q2 and Q3. What it says that? Q0, Q1, Q3 and Q2, right? That means what? It contains all four states. So I will perform the union operation, I will club together, and the new state I am going to get is what? Q0, Q1, Q2 and Q3. Done. So this is, I have considered this, right? And what is the next new state? New state is what? This Q0, Q1 and Q3. So for this state also we need to find it. We are going to perform the same step again and again till we execute or till we consider all the new states, right? I need only one newly generated state here. So here we just got the transition on this state Q0, Q1, Q2 and Q3. On 0 we are getting the new state called as a Q0, Q1, Q2, Q3. On 1 we are getting the same state called as a Q0, Q1, Q2 and Q3. We were here. Now we'll just find it out whether we are getting any new states or not. So here Q0, Q1 and Q3, this is a new state I am going to get. So I need to consider this state as a new state and I need to find out the transition on this state, right? So we are going to find it out the transition on this state that called as a Q0, Q1 and Q3. So this is Q0, Q1 and Q3. On this state, I am going to find out the transition on 0. So what is my state? Q0, Q1 and Q3. So I need to mark these three states Q0, Q1 and Q3. Right? On 0, I need to find it out how many transitions are there. From Q0 on 0 where it goes to the Q0, Q1. And the next state was my Q1. Q1 says that from Q1 on 0 it goes to the Q2. This is my newly generated state again. And from this Q3 there is on 0 there is no transition. So what I need to do, I need to club this state together. I need to perform the union operation of these two. What it says that Q0, Q1 and Q3. So Q0, Q1 union Q3 is what? Q0, Q1, Q3. So Q0, Q1, Q3 is a new state. Q0, Q1 and Q3. This is the this state is my next state on 0 from this state, right? So on 1, on the same state Q0, Q1, Q3. On 1 I need to find out the transition Q0, Q1, Q3. So I'll mark these three states Q0, Q1 and Q3 and I need to find it out the transition on 1 from these three states, right? So Q0 on 1 it goes to the Q0, Q1 on 1 it goes to the Q1, but Q3 on 1 it goes to the Q2. So the new state is what? The next state is what? Q0, Q1, Q2. The Q0, Q1, Q2 is the next state Q0, Q1 and Q2 on 1, right? So I was here last time, right? So I need to find it out whether any new states are generated in this DFA transition table. So I'll just check it out. Q0, Q1, Q2 and Q3. I already find out the transition for this state. So this state is also over. This is a new state. This is the next state Q0, Q1, Q3 that has already been covered. Right, and this Q0, Q1, Q2, this is a next state, right? And I need to find it out, this Q0, Q1 and Q2 that has already been covered. So no new states are there. So this is my transition table for DFA, right? So this is our transition table for DFA, but this is not complete, right? We got many new states here which was not there in my original NFA. So what to do now? How to draw a DFA and how to conclude which is my initial state and which is my final state here. So initial state is not going to be changed. Initial state in NFA was Q0. It will remain as it is in my DFA. But here you come to know that in the given NFA, Q3 was my final state, right? And here in the newly generated state, I am going to have a number of states has clubbed together and form a single state. And in all those states, wherever I find it out Q3, because Q3 is my final state here, right? So wherever I am going to get in my set, a new set of states, Q3 is present, all those states will act as a final state in my DFA, right? So here I'll find it out, this Q3 is here in this set of states. So the complete state will act as a final state here because Q3 is present here. Q3 is one of the member of this set of states, right? Again the Q3 is here and Q3 was my final state in my NFA. So wherever Q3 is there in this table, so that state will act as my final state. So here I am going to get the two final states in my DFA, right? So this is the DFA transition table, but this is not yet complete, right? We are not yet finished. So what to do? We need to find it out whether any duplicate entries are present in this table or not, right? So whenever we checked it out, we find it out there are no duplicate entries. There are no duplicate entries, right? As it contains no duplicate entries, all the entries are unique on all the transition. So there is no scope of reduction of this table. So this will be your final DFA, right? So I can easily draw the transition diagram from this table, right, for the DFA. So I'll start drawing the transition diagram for this DFA. It will start from what? It will start from the Q0. Q0 is my initial state that will remain as it is. So this is my DFA. This is the transition diagram. Right. So here from on Q0, where it is going to the new state called as Q0, Q1. This is Q0, Q1. On 0, it is going there. On 1, it is having a self transition. And from this newly generated state Q0, Q1, where it goes on 0, it says that it is going to Q0, Q1, Q2. So on 0, it is going to the next state called as Q0, Q1 and Q2. Right. On 1, it is going to Q0, Q1. It is a self transition. On 1 here. So this state is over, this state is over. Now this is the state where I need to find it out, the transition which is there, already find it out in my transition table. Q0, Q1 and Q2. So Q0, Q1 and Q2 on 0, where it goes? It goes to Q0, Q1, Q2 and Q3. So this is the next state. Q0, Q1, Q2 and Q3, and here it present Q3, and Q3 is my final state. So the whole state will act as a final state. So where it is on 0, I am going to get this transition, and from this state on 1, where it is going? It is going to Q0, Q1 and Q3. So on 1, it is Q0, Q1 and Q3. Right. So this is the next state, Q0, Q1, Q2 and Q3. For this state, I need to find out a transition. On 0, it goes to the self state. On 1, it goes to the self state. So here, on 0, 1, there is a same transition, right? So this is a new state, that is Q0, Q1, Q3. So Q0, Q1, Q3, this is the state. And for this state, I need to show it the transition on 0. On 0, where it goes? On 0, there is a self transition, and on 1, it goes to Q0, Q1 and Q2. On 1, it goes to Q0, Q1 and Q2. So this is the final DFA for this given NFA. This state Q0, Q1 and Q3, it contains Q3, and I have already marked here as a final state. So I need to treat this state as a final state as well. So this particular transition diagram of DFA, it consists of 2 final states, and definitely every finite automata is having only one state, and you will find it out in this diagram. There are unique transition on every input symbols. So you won't get any duplicate or multiple transition on same input symbol on any of the state in the DFA. So this is the definition of DFA, and we got the DFA from the given NFA. Thank you.